In contrast to a clinical trial, epidemiological studies are done retrospectively or after the fact. In an epidemiological study, data is collected from large numbers of people to determine the effects on public health of a wide variety of factors. Epidemiological studies are often used to determine how diseases spread or assess the risk of certain behaviors, such as smoking. The first epidemiologist was a physician in London named John Snow. During a horrific outbreak of cholera, Dr. Snow tracked the deaths from cholera on a map of the city. He was able to determine that the people who were getting sick from cholera were drinking water obtained from the Broad Street pump. Dr. Snow didn't know it at the time, but cholera is spread by a bacteria that is ingested by drinking contaminated water. It causes diarrhea so severe that people frequently die of dehydration. In places like London in the 1800s, where there is no water treatment, the human waste goes back into the water, the River Thames in this case, and the bacteria is passed to the next person who drinks from the river. Dr. Snow had the pump handle removed from Broad Street, and the epidemic subsided. You can see how this strategy is different than a clinical trial. John Snow did not have some people drink water from the Broad Street pump and other people drink water from a different source to compare them. That would be a clinical trial. Rather, he looked after the fact at who got sick and where they had gotten their water. Epidemiologists often look at the effects of geography on human health and behavior. In this map, the darker areas illustrate areas where teen pregnancy is highest in the United States. Some epidemiologists might compare the rates of gun ownership by state. However, geography is not always what's being assessed. Another epidemiologist might look at how the accidental shootings of children correlate with gun ownership. You can see very easily how it would be impossible to use a clinical trial to do these kinds of studies. In the last 10 years, there have been quite a few studies looking at cell phone use to see if people who spend a considerable amount of time on their phones have a higher risk of cancer, especially brain cancer. I hope you can see from this graph that while the rates of cell phone use have gone way up, the rates of cancer have stayed fairly constant. You don't have to give up your cell phone. Phew! Here is another epidemiological study, this time showing a positive association. Measles is a dangerous disease, and it used to be a rite of passage of childhood. However, you can see with the introduction of the measles vaccine, the disease was virtually eliminated. Measles has actually been making a comeback. A lot of parents have been declining to get their kids vaccinated these days. Measles is airborne and very contagious, and it comes right back when enough people are unvaccinated. The last comment I want to make about epidemiology is that we all need to be careful when evaluating epidemiological data. Just because two things are associated does not mean that one thing causes the other. In this graph, you can see that the rates of the developmental disorder autism correlate nicely with the sales of organic food. Does this mean that organic food causes autism? Probably not. This is a great example of how correlation does not mean causation. Epidemiology can be essential in highlighting relationships, but often more study is required to prove that one factor causes another.